With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, I am going to explain this question, and the question is two satellites of Earth S1 and S2 are moving in the same orbit. Alright, the mass of S1 is 4 times the mass of S2. Which one of the following statements is true? Okay, so let's just solve for a general satellite. Let's say a satellite which is a mass m and it is orbiting around the Earth, which has a radius r. Right? Okay, so we have assumed that orbital radius is r and mass of S1 is 4 times that of S2, right? So mass of S1 is 4m and mass of S is m. Right. So for a satellite, like the gravitational force acts as a centripetal force, or in other potential energy, simply gravitational potential energy, which will be minus g m capital M, that is mass of the Earth, multiplied by 4m, right, divided by r. Similarly, potential energy of S2 will be G capital M minus G, minus will be there, and multiplied by M upon R, right? So clearly we can see that the potential energy of S1 is 4 times that of S2, right? And the option A says that the potential energy of Earth and satellite in two cases are equal. That is definitely false, right? We can say option A. Now let's look at kinetic energy, or let's look at velocity first. All right. So for any satellite, gravitational force acts as a centripetal force, right? So we will get Gmm upon r square is equal to mv square upon r, right? That is mv square r is a expression for centripetal force. So this gives us V is equal to Gm upon R whole root, right? As we can see, the velocity depends only upon R, G and mass, which is mass of Earth. It does not depend on the mass of the satellite. And since they are moving on the same orbit, so R is same, it means velocity will be same. Okay. So we got satellite which has a potential energy different, but velocity is same. Now let's look at kinetic energy. Kinetic energy will be simply half mv square, since m is m is different, so kinetic energy will also be different, right? Now let's look at time period, right? So we know that time period is simply 2 pi r upon v, right? So we have already calculated v, which is gm upon r. So we'll get 2 pi r upon root under gm upon r, which gives us time period is 2 pi r root r upon gm. Still this is constant because r is fixed for both of the satellites. So mass is center of mass is the of Earth, which is also same. So time period will also be same, right? Now if you look at the option A says the potential energy of Earth and satellite in two different cases are equal. That is false, but only option which is true is option B. Okay, and option C says kinetic energy is different, which is same, which is also false, and so is option D. All right, so our answer will be option B. This was the explanation. Bye bye.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.